This video is going to cover my latest version of a flat earth with 2-star rotations, and on screen is the AE map centered by the equator near the prime meridian before I made any adjustments. And just so everybody knows, anywhere you center an AE map except over a pole, you do get 2 rotations. So only if you center it directly over the north or south pole do you only get 1 rotation. On screen is my latest version, and I've made improvements each time, this being the best so far, but don't get me wrong, it's still a work in progress. I've added perspective as if we're viewing it from the center. And the distances we will check later in the video, but they should be pretty close. Also, we'll be comparing our sunrise and sunset angles at the extremities to SunCalc and see if they work. The reason I started working on this model in the first place is because they said it was impossible to have 2-star rotations on a flat plane. So just to cover the basics, you see on screen there's a north and a south pole. Any direction away from the north pole is south, and any direction away from the south pole is north. And you also see a continent of Antarctica, and on the outside is an ice barrier containing the world's oceans. And anywhere on this map, if you travel in a straight line far enough, you will hit the ice barrier. That covers the star rotations. Now you see the top circle is 23.4 degrees north, or the Tropic of Cancer. The bottom yellow circle is the Tropic of Capricorn, and the red circle is the equator. So I start off with the sun traversing over the Tropic of Capricorn during the winter solstice around December 21st. And then it's going to traverse to the equinox. And from the equinox, it's going to traverse to the Tropic of Cancer during the summer solstice around June 21st. So I need to cover a couple more things about distances and angles. I mentioned perspective earlier. Now you see the lines coming off the North Pole there? They all represent roughly the same distance, and everything is south from the North Pole. But if you're along that bottom line, say like right there in America, and you would move that dot down to where you're at, and that would be your east, west, north, south directions. Here's an example. So if you're right here in the middle of America, you draw a line from your position to the pole. 90 degrees from that represents east and west. Same thing in the south. You draw a line to the south pole and you set your east and west 90 degrees to that. So let's say we're trying to position Hawaii. So it's around 21 degrees latitude. So we'll start off in Los Angeles, like right here. We'll draw our line north, and then we'll determine our east and west and go from there. So checking Google Earth, from the west coast of America, we got to head slightly north of east to get to Hawaii, and then end up traveling slightly south of east, which works if it's right here. Now, if you traveled south from Hawaii, a place where nobody really goes, you'd hit the ice barrier. And that's also where flights have come up missing, and where Antarctica's unclaimed. The time zones are all messed up. There's a lot wrong with that area we'll talk about later. Right now, let's look at the distance between Cape Town, Africa, and Perth, Australia. It's about 5,400 miles. So let's go with a distance we're familiar with. We know that across America is roughly about 2,500 miles. So we stretch a little ruler there, and we copy it to Australia. It's about the same distance, and then we go once and twice, which makes 5,000 miles, and we're just short of Cape Town, so that particular distance seems to be pretty accurate. Let's check the sunrise and sunsets on the extremities. So first we'll check the west coast of the United States, and we see the SunCalc says the sun sets southwest. So we draw our line south, and we see that the sunset is roughly southwest, so it's in the ballpark. Let's go to Australia and check the sunrise angle on the summer solstice. So it's showing it northeast. So we draw our line south from Australia, and we see indeed it is a northeast sunrise. So now let's check South America's sunset. SunCalc shows a northwest sunset. We draw our line south, and we see that it is west of north. Sunset is in the ballpark. Lastly, we'll check the sunrise from east coast of Asia. SunCalc shows it southeast. So we draw our line north, and sure enough, it's east of south.
All aboard the great space hoaxer. I might puke if I see another NASA poster. Every damn year, if you tax us billions, then start the countdowns at T-minus a trillion. Flippity-doo-dah, flippity-yay, stuck on the launch pad for 30,000 days. We'll grab the truth, point and laugh at ya. You'll grab a laptop and blast off with NASA. It's your damn dream, it's not our story. For us the financing shouldn't be mandatory. Where's the payoff? Where's all the dividends sitting on the shoulders of hard-working citizens? It's not like the space shuttle's odometer was flipping. It's not like they're out there mapping solar systems. I got a feeling when they're put in their caskets, they're going to a place in a handbasket on a highway to Helio. That won't be the place that we go. So dream big, reach for the sky. Just quit reaching on all our dimes. Reach with your own cash flow. We'll see how far you really go. We'll grab the truth, point and laugh at ya. You'll grab a laptop and blast off with NASA. It's your damn dream, it's not our story. For us the financing shouldn't be mandatory. Where's the payoff? Where's all the dividends sitting on the shoulders of hard-working citizens? It's not like the space shuttle's odometer was flipping. It's not like they're out there mapping solar systems. I got a feeling